In today's lecture, I am going to cover a topic that doesn't exist in most other programming languages, that is, the nullable type. Hello and welcome to Learn with Tam. I am Tarique Ali Mirza and my goal is to make you a kick-ass Android developer. If you are new here, I suggest that you start watching this series from the beginning to get the most out of it. In the last few videos, I have introduced you to variables and data types in Kotlin. In today's lecture, I will introduce you to the concept of nullability. So, without further ado, let's jump right in. To follow along, open Android Studio. Click on Create New Project. Select No Activity and click on Next. Give your application a name. And then click on Finish. In your Project Explorer, expand the App folder and then the Java folder. And then right-click on your package folder. Select New and select Kotlin file. Give your file a name. And then press Enter. Once your file is open, write the entry point function. As I have stated previously as well, whatever code we will write within this main function. Unlike most programming languages, the value of a variable in Kotlin cannot be null. For example, if I do something like this, as you can see, the IDE is already complaining. Null cannot be a value of a non-null type string. That means you cannot store null within a variable of type string. Let us check if it is possible to store null within an integer. I guess you get the point. It is not possible to store null in a simple variable. So, what if you want to create a variable that can have a null value? Well, in that case, you will have to declare the variable as nullable. Let me show you how. As you can see, I added a question mark next to the type declaration in both my variables and the IDE stopped complaining. The question mark after the type declaration implies that this variable is now of nullable type, which means that the value of these variables can now be null. Therefore, there is no need to complain anymore. Please remember that once you declare a variable as nullable, the compiler puts many restrictions on them to prevent improper use. Let me show you an example of one such restriction. As you can see on line 7, I am trying to assign the value of my string to a new variable named newString. Please note that the newString variable is of type string, whereas the myString variable is a nullable string. Even though the nullable string has a value in it, the Kotlin compiler is still complaining. So, in case it wasn't clear already, you cannot assign a nullable value to a non-nullable variable. So, what should you do in such situations? The answer is pretty simple. You have to first check whether the value stored in myString is null or not. If it is not null, the assignment is possible. If it is null, the assignment is not possible. Let me show you how we can do that. As you can see on line 7, I have introduced something called an if statement. For those of you who are familiar with if statements, this line must be pretty easy to understand. For the rest of you, all I am trying to say to the Kotlin compiler is that if myString is not equal to null, then store the value of myString within newString. Otherwise, don't do anything with it. So this line will only be executed as long as myString is not equal to null. And since I have stored the value tam within myString and it is not equal to null at present, this line will be executed. Let me show you the output as well. Let me run the program so that you can see the output. As you can see, the output is tam, which is exactly what I stored in myString. And it is now stored within newString as well. As you can see, the compiler has absolutely no issues as long as we are checking for nullability, which makes us more responsible with our code. Moving on to the next restriction. The compiler does not allow you to access a property or a method on a nullable variable unless you check it for nullability. Let me show you an example. As you can see on line 12, when I am trying to access the length property of my string, the compiler is complaining. Let us try it with an if statement now. It works. Even though this method works, there is a better way to do the same, with a safe call operator. Let me show you how it works. I'll comment this code out. On line number 16, I am using the safe call operator to access the length property of my string. Without the safe call operator, accessing the length property was not possible. So, what happens when you use a safe call operator? Behind the scenes, the compiler checks if my string has a null value or a non-null value. If it has a null value, then the property length is never accessed and the code moves on to the next line, skipping everything on this line. If the value within my string is not null, then the length property of that value is accessed. That way, we are making sure that we don't try to access the length property of a null variable, which will lead to a null pointer exception. Now let me show you another example of using the safe call operator to call a method on my string. As you can see on line 17, I am calling the toLowerCase method on my string using the safe call operator. If I try to do the same without the safe call operator, the IDE should start complaining. Let me show that once again. As you can see, the IDE is already complaining that only safe or non-null asserted calls are allowed. Let me change that back to a safe call. I will write the print statements for both the length and the lowercase string so that you can see it for yourself that everything works as expected. Now let's run the program. The first print statement is from line number 9. The second print statement is from line number 19, which is just printing result, and result is nothing but the length of my string. The third print statement is from line number 20, which is printing the lower string, and lower string is nothing but the lowercase version of my string. So the safe call operator works exactly as it should. Moving on, if you wish to remove all the restrictions imposed on your nullable variable by the Kotlin compiler, you will have to use the Not Null Assertion operator, and that is nothing but 2 exclamation marks. Let me show you how it works. As you can see on line number 25, I created a nullable int named count and added the value 10 to it. And on line number 26, I use that count variable and increment its value and store it in incremented count. Everything should work as expected. Let me print the incremented value so that you can see the output. Now before I run this program, let me comment out the code from the previous examples. Now let's run this program. As you can see, the initial count that I stored in the count variable was 10. The incremented count, which is nothing but count plus 1, is 11, which is exactly what we expect. So why am I saying there is a problem with this approach? Let me show you. As you can see on line number 25, I have changed the value of count from 10 to null. Now when we go to line number 26, we are trying to increment the value from null, which is impossible. Therefore, we are going to get a null pointer exception, even though the compiler and the IDE are not complaining at the moment. Let me run the program so that you can see it for yourself. As you can see, we get the exception in thread main kotlin.kotlin null pointer exception, and the line is number 26. That is exactly where we use the not null assertion operator to tell Kotlin that our value is not null. Even though on line number 26 we are saying that count is not null using the null assertion operator, we are storing null on line number 25. Therefore, we are getting an error. So, you should only use not null assertion operator when you are absolutely sure that the value stored within the variable at that point will not be null. Let me change the value back to 10 and run the program once again. As you can see, it works as expected as long as the value is not null. Now let's say that you come across a situation in which if your nullable value has some value stored in it, you want to store it in another variable. And in case the value stored within your nullable type is null, you want to store a default value in that variable. Let me show it with an example. On line number 31, I am checking if the username is not equal to null. When the username is not null, I am saving the value of username in display name. Since username is not null, I can store its value within the display name. Else, which means if username is null, I am storing guest in the display name, that is my default value. Encountering such situations is very common when you are working with a nullable type. Therefore, Kotlin has a special operator dedicated to this situation. It is called the Elvis operator. Let me show how we will do the same thing using the Elvis operator. To show you that, I will comment out all this code. On line 39, you can see me using the Elvis operator to do everything that we did from line number 31 to line number 35. Isn't this a lot more concise and better? This is exactly how Kotlin helps us write better code faster. On line number 41, I am now printing the display name. Let me run this program so that you can see the display name that gets printed. As you can see, since the username had the value tam in it, the display name now has the value tam in it. Let me change the username from tam to null. Now let's rerun the program to see the current output. Earlier when we had the value of tam stored within username, the Elvis operator checked the username and it found tam stored within it. So it passed that value to display name and tam was printed in the console window. But this time, since we have null within our username, when the Elvis operator checks the username, it has a null value. So instead of passing the value of username, it passes the value guest to the display name string. And that's exactly what we see when we print the display name in the console window. Now, let me change the username back to some other value so that you can see it once again. As you can see, I have changed the value of username from null to some user. So we expect that the console window will show some user as the output. Let me run this program so that we can verify if it is working as expected. It worked exactly as we expected. To recap, the Elvis operator checks our variable for a non-null value. In case our variable does not have a null value, it passes that value. And in case our variable has a null value, it passes the default value that we have provided to it. Now let's move on to another useful feature within Kotlin that helps you work safely with nullable types. Let me write down the code so that I can explain the usage of the let function. On line number 44, I am creating a function that takes one integer as its argument. If you don't know how to write a function, don't worry about this. Just know that this function will take one number as its argument, and that number cannot be of a nullable type. As you can see, on line number 44, our function incrementer takes a non-nullable integer as its parameter. And on line number 49, we are trying to pass it the count variable, which is a nullable integer. And that is why Kotlin is complaining. It is saying there is a type mismatch. The required value was of type integer, but I am providing a nullable integer to it. So how do I use this function incrementer to increment my count variable? There are a lot of ways in which we can solve this problem. Let me show you how to solve this using an if statement first. As you can see, using the if statement, I am able to solve the problem. But there is an even better and more elegant way to do the same thing using scope functions. In particular, the let function. Let me show you how. As you can see, on line number 54, I am using the safe call operator to call the let function on the count variable. The let function, just like the other scope functions in Kotlin, allows you to execute a block of code in the context of an object. For example, in our case, the object is the count variable. We are using the safe call operator to call the let function. So if the value of count is null, this let function will not be called. If the value of count is not null, this let function will be called, and the value of count will now be accessible within this block of code in the variable it, that is spelled it. Even though the count variable in itself is a nullable integer with int and a question mark, the it variable that you see inside, you can see a little gray text written here. It says it of type int, which means since we are using the safe call operator, only if the value of count is not null, that is, it is an integer, is the let function called. And inside that let function, the value of count is an integer. So we can use this it variable inside our incrementer function. And then we will get the incremented value of our count. Let me print this value so that you can see the output. As you can see, earlier the value of count was 0 and now after incrementing the count, the value is 1. Let me change the count value to some other value and let us rerun this program. As soon as the incrementer function was called, the variable 8 was replaced with the value 100 and that was sent to the incrementer function, which only called the increment function on that number. So 100 was added with the value 1 and you get 101 stored in the new count, and then we printed new count, so we get 101. And that is how easy it has become to use nullable types in Kotlin. That was a lot of information to cover in one video, and before you get bored, please remember, these are the same concepts that we will be using time and again while building our Android applications. But before we jump back into Android Studio and start developing Android apps, there are a few more topics that I need to cover in Kotlin. For example, the operators and expressions, which will be covered in the next video. That's all for today's video. As always, feel free to share your valuable thoughts and feedback in the comment section. If you liked the video, smash that like button. If you are new to the channel, consider subscribing. And don't forget to hit the bell icon to receive timely updates of all future uploads. I'll see you in the next one.